All right, let's jump right in. Have you ever wondered, with all these programming languages out there, C++, Python, heck, even Fortran and Lisp, why don't we just use one? I mean, wouldn't that just be easier? Seriously, why is there such an incredible diversity of them? It just seems kind of inefficient, right? Well, the answer isn't in the syntax, the brackets and semicolons. To really get it, we have to dig a little deeper into the philosophy behind how these languages are actually designed. You see, the real reason we have all these languages is because they're not just tools. They're more like frameworks for thinking. Each one gives us a different way to express an idea, a different way to attack a problem. And as you know, different problems need totally different ways of thinking. And that brings us to the biggest, most fundamental split in how programming languages think. It all boils down to one simple question. Are you telling the computer how to do something, or are you just telling it what you want? This is the classic split between imperative and declarative languages. I love this analogy. Think of it like giving directions. The imperative way is giving step-by-step instructions. Okay, turn left at the light, go 3 blocks, then make a right. Super explicit. But the declarative way? That's like just plugging an address into your GPS. You don't care how it gets you there, you just care about the destination. You declare the what, not the how. And you can see this exact idea laid out right here. Imperative languages on the left, they're all about describing the control flow, the step-by-step process. Declarative languages, over on the right, are all about the desired result without getting bogged down in the how. This is really the core philosophical difference we're talking about. Okay, so whether a language is telling the computer how or what, we can pretty much judge any of them using 3 core ideas. Let's call them the 3 R's of code. Yep, these are readability, writability, and reliability. And here's the kicker. These 3 are always in a kind of tug of war. Every single programming language out there is basically a different compromise, a different balancing act between these 3 things. So let's start with readability. Now, this sounds super obvious, but you'd be surprised how crucial it is. Think about it. Code is read by people way more often than it's written, especially if you're on a team or you have to look at your own code a year from now. If nobody can figure out what's going on, you've got a big problem. And check this out. It's a perfect example of how a simple design choice can make a huge difference. You've got the older Fortran syntax at the bottom. It literally says do and undo. It's pretty hard to misunderstand that, right? Compare that to the C++ syntax, which is loaded with brackets and semicolons. It's a subtle thing, but those little choices really add up when it comes to readability. All right, next up is rateability. This is all about how easy it is for a programmer to just get their ideas down. Does the language give you the right tools for what you're trying to build, or is it fighting you every step of the way, making you write pages and pages of code for something that feels like it should be simple? And a huge part of writability is this concept called abstraction. Abstraction is basically the art of hiding complexity. It's like taking a whole bunch of complicated steps and wrapping them up in one simple command. This is what lets us build massive, powerful programs without our brains exploding from all the details. It just makes code so much easier to write and manage. And that brings us to our third R, reliability. And this one is, well, absolutely crucial. A program is reliable if it just works. It does what it's supposed to do every time without crashing or spitting out weird errors. And the design of a language can either be your best friend in preventing errors or your worst enemy. Type checking is a perfect example of this. So imagine you tell your program to expect a number, but whoops, you accidentally give it a word. Some languages like C++ are super strict. They check for that mistake at what's called compile time. That's before the program even starts. It catches the bug right away. But other languages, like Python, they're more relaxed. They wait until runtime, which is great for flexibility, but it means that error might not pop up until a real person is actually using your software. Yikes! So, how does all this stuff, readability, writability, reliability, actually play out in the real world? Well, the way a language chooses to balance these 3 things gives birth to entire styles of programming, what we call paradigms. Probably the most famous one you've heard of is object-oriented programming, or OOP. It was basically invented to solve a massive problem. As software got bigger, the code became a tangled, unmanageable mess. OOP's big idea was to bundle data together with the functions that use that data. They put them in these neat little packages called objects.
This made writability and reliability way, way better for huge, complex systems. And a core idea in OOP, inheritance, is a perfect example of this. Inheritance lets you create a new thing, a derived class, that automatically gets all the powers of an existing base class. Think about that. It's a huge boost for writability because you're not writing the same code over and over. And it's great for reliability because you're building on top of code that you already know works. Okay, so we've covered a lot of ground, right? We've gone from imperative versus declarative through the 3 Rs and even into programming paradigms. So now we can finally go back and answer that first question we had. And here's the answer. The reason there are so many programming languages is because there are so many different problems. Each language is just a different set of trade-offs. Take Python, for example. It goes all in on readability and writability, which is why it's amazing for things like data science and getting a project up and running fast. But then you have C++, which is all about reliability and pure raw speed. That's why you use it to build an operating system. So you see, there's no such thing as the best language. There's only the right language for the job you need to do. So that kind of leaves us with one final thought to chew on. Maybe the question we should be asking isn't just, what does this language do? But instead, how does this language think? Because once you understand that philosophy, well, that's when you can really pick the right tool for the job. And that's what makes you a better problem solver. Thanks for joining me on this explainer.